everyone. Thank you for joining today's IEEE session with Western Digital and Ted Marena, who is also the board of director of the IEEE Alliance. And on agenda today, we have consumer technology introduction of the IEEE with yours truly. Then we'll talk about the RISC-V and rapidly growing ecosystem. And the reason I'm bringing that second time is because RISC-V is becoming very popular in several verticals, including data analytics and embedded, especially with the recent changes in and the lack of chipsets and a lot of other issues which are popping up in the semiconductor industry. And during today's meeting, I would like to encourage everyone, please post questions, do tweets, ask anything. We have a Q&A in a webinar, so please, please, please post. On the IEEE chapter for consumer technology for 2021, you probably met everyone except Palak. Palak Talwar is our newcomer, and she is a co-chairing marketing with Michael Wong. You also know Dev, Avid, and Pat, so you met everyone. We're always looking for volunteers. So if you know anyone who wants to talk, if you know anyone who would like to present or help with society, please join, please share. We hopefully will start on-site sessions as well in this fall of this year. So we'll do most likely a hybrids at that point, where we'll do the webinar versus and the on-site. So you have ability to talk to everyone from the IEEE chapter and communicate not only virtually, but physically and vice versa. So, yay! The next meeting will be in August or in September, and we'll do announcements. Right now, we're still making a decision if it's virtual or on site, and partially it will be presented NXP and one more speaker, which we will announce later on in July. So you will see the email from Palak talking about it. IEEE members, I will not poll it for now, but I would like to thank everyone for joining. We also want to do the call to action and become the consumer society members for the IEEE. So this is a current membership fees. And if you have anyone who would want to join, there is a awards program for recommendations. So everyone can earn some money. That's, I call it passive income. You can sign up for the and one of the benefits, I'm sure, is IEEE magazine. So some of you are publishing. I know Dev is working on publishing an article. And if anyone is else interested, please, please, please do so. So if you have, like I said, speakers, please send it to me. There is a job opportunities. If anyone has anyone who wants to be hired, or anyone is looking for a job, we can help to facilitate it. So like I said, please contact us. And this will takes us to the today's introduction, and that is Ted Marena and the presentation on RISC-V. So let me introduce you to Ted. Ted Marena is Senior Director of Business Development at Western Digital. He's also a board member of the consumers of the RISC-V Foundation. Ted, did I do it right?
Actually, I'm the marketing chair for the foundation.
Okay.
So that's, you know, on the board, but technically the marketing chair.
Okay, you're still on the board, so I didn't do it completely wrong.
Right.
You still
right.
are on the board. Okay, and Ted is responsible for evangelizing RISC-V, accelerate and build out ecosystem and marketing machine learning solutions in his own storage space. So Western Digital, I'm guessing, is his own storage space, and RISC-V is an ecosystem. On that note, the topic of today's is consumer applications and leverage of the open ISI. RISC-V is the driving force behind the next generation of compute for embedded consumer and cloud applications. So Ted will talk about the RISC-V overall. Hopefully you will cover some of the topics like the Sci-Fi and other companies, what they're doing with the boards and in the ecosystem. And the RISC-V is becoming one of the most common technologies for IoT and embedded devices. It has an optimized architecture, which allows addressing storage, power consumption, and ease of adaptability. During this session, we'll talk about what is happening with RISC-V, where does the market take us, what are the latest trends and most innovative approaches, who is adopting and building silicon, software, hardware, applications, and RISC-V architecture. This is a little picture which I snapped from RISC-V on the foundation members today. So it's a 65 and growing. And on that note, allow me to stop sharing. And I will pass the floor to Ted. Ted, the floor is yours. And everyone, I will start adapting everyone and allowing this to talk and ask questions as we go, but everyone will be unmute for time being.
Okay, so you can see the full screen here?
Yes.
Okay, great. Great. Well, welcome everybody. I'm not sure if the plan is for people to type questions for chat or whatnot, but Olga, if you can just kind of guide me.
Yeah, so let's do this. If there is a questions, we can do Q&A. At the end of the session, if you allow me like 5-10 minutes, we can do voice questions as well. Okay,
that sounds good. Okay, so let me get started here. This is the overall agenda, and let me just minimize the picture of myself. So what I want to do is just provide sort of a background, just a couple of slides. Some people still don't and aren't familiar with RISC-V, so I think it's very important to just kind of baseline everybody. One of the areas then we're going to shift to after that is talk about what's happening. There's a lot of different analysts, media, and others that have actually dug in and had a lot of data across organizations. So this is kind of some interesting data, and I was pleasantly surprised as I've been seeing it over the last few months. And some of you may be very surprised when you see some of the numbers. And then I'm going to actually kind of get into the nuts and bolts of the presentation. I think it's very important to kind of show you progress, what's been going on. And my existence with RISC-V, just for reference point, I started in 2017 as the marketing chair at that time. Anyway, I'll get into it, but I've really seen in the last 4 years, significant growth. And I'm going to get into as many consumer examples that I could either collect or find. And one of the real challenging parts of doing this presentation for you is many companies just aren't willing to share where they're using the technology. There's a number of reasons for that. But, when there's public information, we are sharing it. We do want to make sure that it's as visible as we can make it. And certainly being in marketing, I want to talk about it and I want to promote it and make sure that you're aware. And then I'll just one slide summary. So with that, let me just kind of get started on the first section here. Okay, so RISC-V. So what is RISC-V? Some people think it's a processor architecture. That is not actually what it is. It's basically an open instruction set architecture. So it's a specification that has these particular instructions, and the way it's set up is fairly modular. There's a base set of instructions that's just under 50 total. Everybody has to implement those. And then there are extensions that you can or you don't have to implement, depending upon if you need them. In the past, I would get into a lot more nuts and bolts about, integer, multiply, etc. But it's not really where I want to go in this presentation. The point is the modularity allows us to participate in several different markets. And the openness allows this to be across the globe, very, non-geo specific, which is becoming more and more critical as the political winds shift and change. So I like to talk about the fact that RISC-V is really opening a lot of doors. If you actually just rewind about 10 years ago and think, what processors did you actually have an option to use? It was extremely limited, and in some sense, it's still very limited. And the reality was that because the instruction set architectures were closed, and because the barriers, you basically had to do everything yourself. You had to not only do the design, all the infrastructure, all the supply chain, you had to leverage and, obtain all the different partnerships for tools and such, or develop them. And RISC-V is really removing a lot of those barriers because it's open. It's really being seen by a lot of people as offering many, many opportunities. And just if you can just think about it from an IP point of view, there are multiple, I think there's more RISC-V IP core vendors that you could go to than there are vendors for the other types of architectures that are out there. So what's unique here is, for the first time ever in processors, when you pick an architecture, you don't get locked into a vendor. And I think that that's extremely interesting and compelling for many, many markets. So you can get started, get going with a particular vendor or vendors, whether it's tool chain, IP, software operating systems, what have you, and do a number of development things. And then if you need to change, a lot of your investment is going to be preserved. And I think that that's really key. The one thing I would point out before I continue on is I do want to also let people know when instructions and the specifications are set, they're actually frozen. We're not, the only time instructions are added is when new extensions are added to the specification. So I think that's also very important. If you write software, run it on a RISC-V core, it's going to run on that core or any other core that's the same forever. So there's also a base of stability that has attracted a lot of the folks in the supply chain overall. Okay, just a quick snapshot on members. We have members across all over the globe. I don't really focus on the individuals. What I like to highlight, I started with RISC-V in here in the early 2017 timeframe. I was made aware of what was going on and had attended a conference, got very excited about it. At that time, there were 30 total organizations, period. And forget the individuals, but there's over 200 if you look and count all those up today. So in 4 years, it's more than 6x'd in growth, and it continues. We continue to attract members on a regular basis, and the organization just continues to grow. So there's significant momentum overall. So I also want to share with you, what is the path, like how do people get started? What's the journey? And I think that this is super important to give you an idea of where we are in the timeline. So the early days, as I like to say, were really the start of RISC-V at Berkeley, and then it was opened up, and there were many companies in the Bay Area and in other universities that were associated with this specification that started to dabble, right? They started to do things. Most of these were just internal. But as more and more interest came back from the university and people started networking, and there were these informal then formal get-togethers on a bi-yearly basis, the foundation was created in 2016. And towards the end of 2016 and then 2017, what you started to see was people were using 32-bit cores for embedded applications. So by and large, this is how everybody gets started. You have a more powerful system controller, generally speaking, that is an application processor maybe, and you have like a small controller that does things like power up, management or trimming, monitoring, etc. We also started to see embedded 32-bit cores where they might be connected to state machines that did some acceleration and simpler type of functions, but mostly hidden. It was great to leverage the ecosystem that was available, but these were largely deeply embedded cores. And then what we started to see were organizations taking advantage, and I would say really 2018 was sort of the start of it. 2019, it definitely started taking off, where you started to see it in a lot of IoT. People very soon realized, hey, I am getting a performance benefit. I'm getting a lower power, lower cost because of the sizing. And again, because of the modularity, it's not you have to take this, building block size. You can actually implement exactly what you need, and you don't need to implement more than what you need. So it started to show up in a lot of IoT devices. There was also a really significant announcement by Microchip last year, where they had actually announced a quad 64-bit RISC-V hardened core that was inside of FPGA. So they have an FPGA family, and this quad complex is in each of those architectures. That's their PolarFire SoC. So that is a really interesting architecture, and has a lot of people very interested. And that also helped with other vendors like Sci-Fi and others to accelerate a lot of the Linux focus. And that's really where we have been, I would say, over the last 18 plus months, is focusing on the ecosystem. What are the tools needed for 64-bit cores, Linux capable, starting to actually move up in performance as well. And folks that are even starting to talk about application processors that are based on RISC-V. So not deeply embedded anymore, but now externally facing. So this is kind of the growth path, if you will, of where we've come from. Okay, and again, I mean, if there's questions or whatever, you guys can put them in the chat, and I'm happy to answer them as best I can. Or again, of course, you can ask at the end. All right, let's shift gears here. So I want to kind of give you a few quotes, and then I'm going to show some data and graphs, which is directly from whether it's an analyst, media, et cetera. And I think a lot of people may or may not be aware that the number of OEMs doing their own circuits is actually up and is forecasted to continue to grow. And I think this is very counterintuitive. I think a lot of people are, just blown away by the additional cost that it takes to do development, especially at the more advanced nodes. I mean, not everybody needs all the advanced nodes, and by having an ecosystem that can be leveraged often, you're actually lowering the cost of some of these. And it's just also, I wouldn't say table stakes, but becoming more important to differentiate and innovate by doing your own silicon. So we think that RISC-V is really well aligned to this trend. And I also believe that the open source nature of RISC-V also allows an ecosystem, and it allows contribution across the globe, because every theater can benefit from the specification. So if you're making tools, if someone like our organization, Western Digital, we have done a bunch of tool chain development that we use, but we also upstreamed it. So it's out back, contributing to like GCC compilers and so on. And so, everyone that increments and helps build and improve the entire ecosystem is able to benefit from that. And that's just massive leverage across numerous companies. So I think everybody knows there's lots of connected devices. So whether you bucket them as IoT or other, all of these devices are often going to need custom processing. Security is, I think, becoming a checklist item. Everyone's definition is a little different. So I don't really want to get into that because we could spend an entire hour on that. But the reality is that the varied amount of devices, the varied amount of architectures and implementations, and the proliferation of connected devices is again a great trend that aligns well for the customization options that RISC-V affords. So that's kind of the setting the framework. Now, what I want to do is sort of show you what are people doing with RISC-V, and where do some analysts and others, organizations that have done some surveys and taken data think. And I think this is super interesting. So this is a Semico report, which I'll refer to a couple times in a few future slides here. So they have like 25% for consumer. What's really interesting is that smartphone is actually in communications in their bucket. So about more than half of communications is smartphone. So 25, and say you add, even if you only add 10, that's over a third targeted for consumer type of applications with RISC-V. So this is what the analysts see where the highest interest is. And I think it's also noteworthy where automotive is also pretty large, as well as compute, industrial. Okay. So I may have showed a slide last year that talked about sort of a forecast to 2025. And so this report is actually been updated, and they've revised upward the total cores that will ship. So just to clarify, you may have an ASSP or an application processor, and it may be based on ARM or x86 or whatever, but you may also have 8, 10 or more embedded cores. And so if there are, say, 8 embedded RISC-V cores, this chart would count that as 8. So just so everyone understands what the definition here is when they're talking about cores. The overriding point is that you can see, huge growth. And so again, the consumer bucket here is this maroon one. And then smartphone, again, is in communication. So it's a pretty healthy amount of growth. This was something that I also thought was pretty interesting, is that Wilson Research with Siemens had done a survey, a double-blind survey late last year. They put this out where almost a quarter of all implementations are using RISC-V in one way or another. I think that's pretty significant when you think about all the different possible types of ASICs and architectures. This is, I think, even though they tried to bucket this by application, the fact that you have CPU, MCU here, obviously a lot of these use CPU and MCUs. So it's not perhaps reflective of all where they go, but the key number here is 1 in 4, and nearly 1 in 4, and we believe growing, are adopting RISC-V. I got 2 other pieces of data that I want to show you, and this is just one of the smartphones. So the Semico report breaks down smartphones as low, medium, and high end. The low end is actually extremely high volume, even though a lot of people, Apple would be considered a high-end smartphone, but the low-end market is also, it's extremely sizable. And if you look here, just the unit growth, again, a lot of these we believe are embedded. Some are in, for example, controlling the antennas. Some are doing sensor hub type of functions. Some are in the image signal processing. These are all areas that are seeing success. And so at 79 million units on the low end, forecast to go to 7.9 billion. So that's a 100x growth in just the next 4 years. Just staggering. Then the other one that I want to show you is total consumer. So their consumer category consists of all of these areas. So again, it's, wearables and such. Didn't mean to change that. Smart speakers, IoT, et cetera. And here, talking about nearly 200 million to 7 billion. So again, continued significant growth. All right, so that's a, kind of a quick background overview. I really want to spend the rest of the time talking about the ecosystem and giving you sort of examples. So the ecosystem, what I was trying to do was to sort of show you sort of what's new, what's happening, and maybe you want to get your hands on some things. So that's really the intent of what I wanted to show you. And when you think about the community of RISC-V, yes, you need hardware, but there's also the software ecosystem. So I'll be going through and talking about various, tools that are available and hardware, right, development that you can get your arms around. And this is not all of them, but it's, a number of them that I felt were most targeted or most likely for consumer / IoT type of applications. All right. So the first thing I want to talk about is, I'm not sure how many folks are aware, but Android now runs on RISC-V. And this was massive news that occurred in the first quarter of this year. So there was an open Android port of Android 10 that Alibaba and others in the ecosystem had done. You may not be able to see in this diagram here, but this is a Shakti processor, which is a 64-bit processor that is part of Alibaba's T-Head group. So they had done the development, they made this board internally, and they have run Android. So this is very exciting news, because we've had a tremendous amount of effort on Linux. That's going to continue as there's more and more infrastructure and tools being done there. But having the Android port also opens up many, many more possibilities. To ensure that the porting, the support, the tools, and the ecosystem around this continue to grow, there is a RISC-V Android special interest group. So it's an organization, it's headed up by both an individual from Alibaba as well as Imagination. And Imagination actually uses RISC-V embedded architectures for their GPUs. And I'm actually happy to tell you that they've publicly stated they actually use Western Digital's RISC-V cores, and they've made enhancements to it, and they use it internally in their architectures for their GPUs. But the point is that there's a closer tie in here with Google and the Android community that we want to continue to do further development, enhancement, robustness, upstreaming, and so on. And anyone who wants to get on the mailing list, participate, et cetera, this is the link that you can sign up for. Okay, let me keep going here. So this is a Beagle Board. So you may know of Beagle Board. In the past, they had a number of different OMAP and other types of processors, and they still support those, but they have become a RISC-V member. About a year ago or so, they had signed on, and they have developed something with a dual 64-bit core from Star5. Star5 is a silicon arm of Sci5, which is an IP company, one of the larger ones for RISC-V. And this, again, designed to run Linux, open source, and I've left a link there. This is either available or just about to be available. But again, it's a really popular form factor, kind of Raspberry Pi-ish with similar capabilities. For those who might want like a little smaller 32-bit, this is a development kit that has a small LCD associated with it. Again, it's only, it's less than $20. It's uses a Giga Devices 32-bit controller, and again, there's some breadboarding area as well. So again, these are architectures for what I think is more of IoT and other types of development. And kind of even further down is a kind of a knockoff replacement for the ESP32, which is like a Bluetooth BLE module that's very popular with IoT. This is actually Bluetooth and Wi-Fi on this really small board and integrated antenna and so on. It's $4. You can get it right there. So the point of why I'm putting all these in is to kind of show you that it's moved from the concept and the idea sounds good to people have made silicon. There's more and more tools available and getting onto boards. Just wanted to see if someone had a question, because I heard one or two people go off mute. Nope. Okay. So I'll keep going.
Wait, Ted.
Oh,
I
sure.
was fighting with my mic. Yes. So Patrick is asking question: are there many companies that help customers to implement RISC-V based ASICs? If so, please name a few. So besides Sci-Fi, what are the other companies?
Yep. So I would say the other two organizations are a company called Codasip, and also an organization called Andes. Andes is a Taiwanese based IP provider, but they have representation all over the globe. They are a major RISC-V IP vendor, and I'll actually show you an application coming up from them in a little bit. Codasip has several different cores. They actually support the Western Digital Swerve core. So the core that we've adopted internally, they actually have full commercial support, and they've made enhancements to those cores as well. And I'm also, if someone wants to hit me up, my email is in this deck. I'm happy to make whatever ecosystem connection links after, no problem.
Yes, so for everyone on the site, the slides will be posted on the IEEE Consumer Technology website, including video, and you can download it. And everyone who is not part of the IEEE, I will download the list and send it out to the emails you signed up with.
And just so you know, Olga, that box link that I sent you, you can share that with others. That is,
oh, wonderful. Then I'll just do that.
Yeah, because the file is like larger than 30 gig, right? It's big.
Yes,
I also wanted to just point out not that I think this is something significant, but some of you have kids or people who just want to tinker, if you will, and really kind of learn. So Sci-Fi actually partnered with the BBC and has this what I call the hand board. It's obviously intended for young kids to get into coding, but there's actually an expansion kit where you can run a few other things. It's quite functional. So Jeff Mulhausen is at Sci-Fi, and he actually said he would give away 5 or 10 of these kits if people really had a need or were going to use it. So I'm not going to make any promises. I told him I'm not involved in shipping, but anyone who contacts him and says, hey, I heard Ted talk, he talked about your hand board, your high five board, and then he's good on his word. So, but if he if he runs out of his allocation, don't blame me. Okay, continuing on. That was kind of I wanted to just throw that in there. I want to just go through just 2 tools that are also available. Ashling is a company that I know pretty well. And actually the next company in Paris I do as well. These guys have been doing the RISC-V development, tools, probes, and so on. They, what's interesting about the Ashling implementation is they really optimize for multiple different cores as well. So you can have like an ARM core and a RISC-V core or ARC core, whatever. You know, so the heterogeneous debug capability is something that you know, they sort of specialize in. So I just wanted to kind of point this out. This is kind of very important, right, to have a lot of different tools. The other one is in Paris. So they have software, more exploratory software, simulation tools, verification tools, and have really, you know, put forward this idea of doing a lot of work in parallel. So you don't have to do the vast majority of the development when the hardware gets back. You can actually do quite a bit of it up front. And I have seen demos where they dig in and show you, you know, loops that are taking longer or other bottlenecks. And you can see they put a list of companies that are public users. All right, and then the one thing before I get to kind of where are people using it, I want to let everybody know this is preliminary. We are in final negotiation on a contract, so I absolutely expect this to happen, but probably still a week or so away from getting that. Once it is public, you will hear about it. The RISC-V Summit 2021. We are going to co-locate with DAC, so we're going to share the Moscone Center. So December 6th through the 8th is the plan. This will be in person, so we'll have keynotes, expo floor, technical talks, but it'll also have virtual options. So for those who can't travel, then they can also still participate. And if you want to get on the mailing list, you can just sign up at events@riscv.org. if you want to be notified. So again, being the marketing chair, I had to put that in there. So let me kind of walk through where are we being used in terms of where's the RISC-V adoption. I talked a little bit about this last year, but I wanted to kind of make the case in point because I think it's really interesting. Is someone like NVIDIA, actually, obviously they have these honking GPUs, you know, complete families. They used to have an internal core that did a lot of embedded applications, and it was cookie cuttered many times depending upon the complexity of their SoC, called Falcon. And they evaluated tons of different architectures, and RISC-V was one of them. And it really was able to address the vast majority of what they needed. And so they have actually moved to it as an internal controller. So they have their own NVIDIA RISC-V Core. Whoops, I'm sorry, I don't know why my mouse is doing that. So this is what they're using in their devices. Some of them, like I said, have multiples per. So this is pretty common. A lot of people, you know, get started this way, and some of them will just, you know, keep using embedded. Others, you know, go on to where they're using it for higher end, external facing, and so on, such as like the microchip example. So in mobile, Google had actually presented at a workshop that their ISP, what they do image processing on, what they call Pixel Visual Core, is actually based on RISC-V. So the image processing unit on many of the Google products uses this processing multi-core. And if you think about it, it's kind of like a co-processor, right? So the IPU is doing a lot of offloading, and the benefit here is that it's doing the processing. The apps processor does not need to wake up, consume all the power. So they're able to run faster at a fraction of the energy. So they're obviously utilizing Google's been a big proponent of RISC-V and open flow, both in software and hardware. And, you know, RISC-V really dovetails well with what they're doing. You may have seen, but probably not, the kind of keynote that Samsung had given. I couldn't get any slides, but this was from a presentation where they talked about some of the use, for example, in their 5G modem. Again, it's an embedded core. This is kind of a picture of their millimeter wave RF, antenna plus power amp, where it's using the RISC-V core. And so that's something that they continue to develop. And again, it's one of these organizations that they aren't super public, but when we have some information, we definitely like to share it because I think it's important to show the adoption. I want to talk about what Andes has put forward. So Andes has a fairly broad line of RISC-V cores that they have IP for and development services, and as well as tool chain and such. But they also are actually have a compelling solution for wireless stereo platform, supporting a lot of different key capabilities. Sorry about that. I guess I need to stop moving my mouse. It keeps thinking I'm going to the left. And so some of the challenges, though, with, for example, doing noise cancellation is that you have to take those signals, create the inverse, and so you can ultimately put out the, and cancel the noise. But to do that, you have to sample very quickly, and you only have, so much time, so many clock cycles to do that operation. And so what they've put forward is a combination of RISC-V plus some hardware acceleration. And I think, the RISC-V is really unique because it gives them that flexibility. So the best way to do it is, hey, just throw it all in hardware, but it's not very flexible. Or, you could have a lot of modularity in hardware, but it would take a lot of power when you have tons of multiply and add summations for all of the filtering. So, what they've implemented is basically a number of 128 tap FIRs that they're able to cascade and connect up. And that, along with the RISC-V architecture and the custom extensions that Andes implements, is allow them to make a very compelling implementation. So this is the platform architecture that they have. And if I just go here, you can see they have these custom extensions, Andes custom extensions that do like FIR and some of the other functions. So RISC-V Core, again, with many of the peripherals needed. And you can, again, see here as a really good example, like why I like to talk about it, because it shows you they implemented what they needed, the modularity. With RISC-V, you can have custom instructions, which they take advantage of here. And, the net benefit is that, they're able to, in only 128 cycles, if you remember earlier, or 250 total, I was saying that they had to do this in less than 800, I think it was. So, they beat that significantly. They're actually able to lower the clock rate as well. So again, that's a power savings. So kind of a few more details, if you will. RISC-V is in a smartwatch. So Xiaomi has a family. This is publicly known as Amazfit, and they use silicon from Huami, which is the hardware, the IP arm, and it incorporates AI functionality as well. So that's kind of interesting, where it's just a low-end microcontroller, but adding some custom acceleration. So they do a number of health monitoring, leveraging the core. They had previously used M4, and the architecture actually uses a Sci-5 device. I think it's a E300. And so again, it's a power savings benefit and customization. This is something that I ran across that I thought was interesting is a portable soldering iron based on a 32-bit device with a small monochrome display. So, you know, for what it is, it's obviously simple, but, you know, it's nice to see things used everywhere. Seagate had announced late last year that they have RISC-V development, and they have silicon. It's actually an out of order speculative 32-bit core. They talk about it being used in future hard disk drives. And this is something that they optimize for real time, because obviously the data comes in and at a certain point you have to respond, place it, and so on. And there are also future workloads that they see. And here too, you can see a you know, significant cycle time reduction that they were able to achieve with their core over legacy architectures that they had to take off the shelf. Western Digital, so I'll just, you know, talk briefly about what has been public from us. This was a solid state disk controller. So the RISC-V core that Western Digital, we actually have multiple cores called the Swerve core. And you can see here the interfaces to a host as well as to the flash itself. So fairly straightforward there. We actually talked to folks about a piece of prototype. So we have silicon, we've made a number of boards, and there's currently a prototype. Can't really say anything more than that. For those of you who do want to be kept up, you can go to westerndigital.com/RISC-V, and you'll see more information on the Swerve cores. There's even a link like Dakota SIP there and so on. And you can kind of get an idea of what it is and stay up on the latest of what we're doing. And I think the one thing that I'm proud of the team at Western Digital is the performance of these cores. So we have what we call our EH2. This is a dual threaded embedded core. So these are 32-bit cores. And this is a single threaded as well as a dual threaded, right? Because it has 2 threads. And so you can see the core mark score here for a single thread is 6. And that's quite a bit higher than similar cores. And this is actually a 64-bit core. So kind of interesting that it's very similar. This is actually a device from ST Micro that has 2 cores, an M7 and an M4. So both of those cores actually are, you know, just somewhat outperforming this dual threaded core. So this is what I think an awesome implementation that we've put together. And you can find implementation or information about these cores, the EH2, on the website, as I mentioned. And of course, the lawyers at my company had me include all the links here if people want to really go and see those core mark numbers. All right, then the last organization I want to talk about is GreenWaves. I think this is a super interesting IoT implementation. They have very, very low-end architectures, really designed for battery, very small size, actually multi-core RISC-Vs, and I'll talk about it. They had shared with me some of the target applications, including noise canceling, stereo headsets, as well as battery powered security cameras, door lock, and so on. Pardon. They actually have 2 architectures. Their first device they came out with was a GAP 8, which was a multi-core architecture that had a certain amount of hardware acceleration to do some DSP and neural networking capability. GAP 9 is their latest architecture. And, you know, that's an enhancement that is made on a little bit more advanced architecture. And, you know, these are, again, really designed for the edge applications, right? The very, very edge. They do have eval boards and such, actually quite a bit of reference design in IP. GAP 8 is in production, GAP 9 they are sampling, and so there's a wide range of, they have tool chain and so on. But, you know, really optimized company that has largely been started and running from RISC-V right from the start. So That's really the entirety of what I wanted to go through. I do want to leave a little bit of time here, so I apologize if I went a little bit fast on some of those. Let me summarize and then I'll stop talking. So RISC-V, it's clear it's accelerating. And, we could talk about, really why, but it's a number of factors. I think when you come down to the power, cost, performance, everybody can relate to that. We know it's being used embedded in many areas, for sure in IoT and growing. And then we think 64-bit and multi-core is kind of the next area. Development tools, the ecosystem overall, continues to grow and support. And it's really, in my mind, it's not a question of is RISC-V, if RISC-V, like, will it survive or will it grow or get adopted? But it's really how large is it going to become? That is, in my opinion, where we have arrived at. So, all right, let me just pause and.
So I have one question. On a global basis, can you please comment on the market share of RISC-V Core versus ARM Core?
I don't have that number. And, the reality is, if you go back to a couple of those slides that I showed, if I can see if I can, I don't know if I can get back quickly, but just like to give you kind of an industry snip. Mm-hmm. Take a look at this one, right? So this is the the total number of cores, right? So there was only 196 million total cores, right, last year that were shipped. That was 2020. Right. So just imagine how many consumer devices that are in these categories.
So basically from 2019 by 2021, you were already building a hockey stick.
Yeah, and I think that this is the point, is mm-hmm. Given the data of what people are doing in development, right? That Siemens report, I think, was significant. The fact that 23% of ASICs and FPGA projects are incorporating RISC-V. Right. Mm-hmm. So this leads to 2 years from today, consumer products.
Right. This is good. Amy, yep. So everyone right now is on mute and can ask live questions. So I would welcome you to unmute your mics and ask questions. So please go ahead.
Okay, I'll jump in. I am mostly interested in what's happening with RISC-V from a DIY hobbyist sort of perspective. Mm-hmm. So I have different, automation and IoT projects in the house. I used Raspberry Pis to build my own cloud. And I know you showed a board from Beagle Board or whatever.
Yes.
But do you see RISC-V like showing up in a Raspberry Pi? Maybe in the future?
So potentially, I think that there have been announcements from a joint venture between UC Berkeley and a prestigious Tsinghua University in Shanghai to develop exactly that, a RISC-V based Raspberry Pi, if you will. So, I think that
talk about that.
Go ahead.
Banggood has RISC-V chips for $13. If you go to Banggood, you could get a, not quite a Raspberry Pi, but pretty good processors. I've been buying them there.
How do you spell that?
B-A-N-G.
Yep.
O-O-D, Banggood.
Okay. And who's the vendor?
I have no different vendors.
Oh, okay. So that's kind of like a site.
Yes. Yeah.
Okay.
Yeah.
Okay.
And
I haven't heard of that. Thank you.
and Costa Rica just created the first CPU in the Latin America based on RISC-V.
Yes. Yeah, they have actually been part of the foundation doing things and have actually had some input because some of the things they're looking at are like medical and a few
Yes.
other areas. Yeah.
Okay, well, thank you.
Yeah, you're welcome. Thank you. Appreciate that.
Yeah, thanks for sharing that. Although, like for my purposes, having the Raspberry Pi has such a strong ecosystem
Mm-hmm.
and compatibility with, other components to the board.
Yep.
That's hard to, it's hard to leave all of that support behind.
No doubt. No doubt. And
I don't know. Are you able to hear me? This is Drew from Beagle Board Foundation.
hey, Drew.
Hey, I just wanted to comment about, since you're talking about the Beagle 5 Starlight board. So that's what we're hoping to be an affordable RISC-V single board computer that can run Linux. And it does have the 40-pin connector there that you see on the Raspberry Pi. And our Beagle Board community has been around for 12 years doing the Beagle Board and Beagle Bone. So we have a very large community, so we're definitely going to leverage that as we move into RISC-V. So if people want to find out more information, you can go to beaglev.org or feel free to email me. I'm Drew at beagleboard.org.
Drew, thank you very much. I appreciate that. I have questions. I will email you.
Yeah, please do. Thank you.
Okay, I'm talking to myself as always. This is wonderful. Thank you, Drew. The question from Ram Prakash: how is it better than FPGA in design cycle, particularly if in reconfigurable? And the second one: development tools, suppliers, and rapid prototypes facilities link. So we need links.
Okay, what was the first question
How
that
is
he
it
asked?
better than FPGA in design cycle, especially if it's reconfigurable?
How is it
How
better?
is it better in FPGA in design cycle, particularly in reconfigurable? Prakash, maybe you can speak up and explain what you mean.
Well, okay, go ahead if he's available.
He's
to.
unmuted.
Yeah, especially if you take some FPGA that is, the design cycle and low power, and everything is available in IDE format. So I can make a design and before going to the SOC that I can make it thing possible. So is it that kind of reduced instruction sets? RISC-V is having such kind of facilities. So how can I switch over from this platform to this?
So I'm not sure if your question is having like a RISC-V soft core that you can target via Verilog, for example, in an FPGA. There are a number of those types of cores that are available.
Mm-hmm.
And so is that what you're asking, or are you asking if you have that, how do I go to a chip?
Yeah, how I got to go to the chip? That is what I'm asking.
Yeah.
The cost. And the...
Yeah, and so I think there are a number of there are a number of vendors that have options for allowing you to go to a shuttle. So Sci-Fi does have actually like a silicon arm that they utilize to go in that type of area. There are also some interesting things with some open shuttles that Google is part of. There's an organization called Chips Alliance, which is like more focused on hardware. They kind of are trying to have a more of an open hardware architecture implementation. And so they've done some things with Google. I'm trying to think of the fab, but there's actually like a fab that, when they have some space, you can have a very low cost entry. God, I can't remember it. I'm sorry, but I can find it and follow up. My email's here. I typed it in. So if you do have any questions, I can follow up and get you that answer.
Yeah, sure. Thank you.
Good question.
Thank you.
Thank you.
Any other questions? Okay, going once, going twice.
Well, we're at the top of the hour. Thank you very
Right.
much, everybody, for attending. I really appreciate it. And hopefully you learned something from the presentation, and you can reach out to me. Thanks again.
And a quick question, Drew just posted the link to Beagle Board and Design on Board GitHub. So I will share it in, well, actually it will be visible to slides. And thank you very much, Ted, for amazing presentation. And it was very informative and very helpful for everyone.
Yep,
On
you're
that
welcome.
note, thank you very much. And we're closing
hello?
this webinar. Yeah,
Hello?
yes,
Sorry, could I ask the last question?
sure, go ahead.
Sorry, this is Danny on Future Way. And my question, I saw the news today that Sci-Fi Intel got to take over about $2 million. Do you have comment on that?
So I actually just saw that news about an hour ago, just before this started. And so what Danny's referring to is Intel supposedly, I think it was put on Bloomberg or Seeking Alpha, that Intel had offered about $2 billion for Sci-Fi. I don't actually know if it's true or not. I don't have any further comment. I'm not surprised. That's all I'll say.
Okay, thank you.
Thank you, everybody.
Thank you. Have a good day. Bye, and have a good
Bye-bye.
night. Bye-bye, everyone.
And thanks, Olga, for arranging this.
Thank you. Bye-bye.
Bye-bye.